So I have pushed the homework, right? Assignment. The next assignment is due next week. And before we start, I want to bring your attention to is that in January, like now until February, you can see 1, 2, 3, 4, 5, 6 planets, but with the naked eye, you are able to see Jupiter and Mars and Venus. With binocular, you could see also Saturn. You are able to see Neptune and Uranus, but that you need binocular won't work. You need a telescope, right? So of course we are not looking right now. The sky is not clear, but Miami has a very bipolar weather. You never know. It can get better. So it's a perfect time to look at the planets. Venus is very, very bright. You can see it at sunset after 7 p.m. You cannot miss it. And again, remember, you can download an app. I don't know the name, Sky Night or something like this. You look at something bright and you look for your phone and it will tell you what it is. And again, it's great. Even if you go for interview, you see, you can talk about um, your passion about astronomy. You can use that as well. Okay, you have the link in Canvas. So I want to see Jupiter tonight, so I'm going to say Jupiter. And of course, this is the day, so you cannot see it, but you see, you can see it here. Right? And it's going to tell you where to look. So if you go down like this, east, southeast, you will be able to see Sirius. So Sirius is the brightest star in the sky, as you already know. You can see it looks like a dog. So it's the star of the color. And you can see, which is great, you can see Orion with Betelgeuse and Rigel. So you can see it with your naked eyes, which is a red giant. And here you have a planet. You're going to be seeing Mars, and you can also see Jupiter, okay, even with your naked eye. You see it's in the constellation Taurus, which is the bull, and it has a fierce eye, remember, Aldebaran. So it's a great time to observe the sky if we stop having this disgusting weather that we have now. And you see, you see Capella. So it's a great time. Okay, you have if you go down here. Okay, so just to tell you, this is the right time to observe the sky. If you can tonight, or you have up to February to do it. What else? Okay, so we are going to start a new unit about history, but I forgot to show you last time. I have this video, which is also very nice, just to put scales in perspective in the universe. So it's a nice video that I forgot. Space shuttle, space station. Oh, a space station, those poor astronauts, and they look terrible right now, that NASA failed to bring back. And I think Elon Musk has to get them with the space station, with the no SpaceX, right? But they have been there for God, like for the last 6 months or something like this. Terrible. They look terrible right now. And you know why? Because you are in space, you cannot work out your muscles, right? We have muscles and we have strong bones because we are always fighting against gravity. Gravity is pulling us down, so we have to stand up, right? So those astronauts, so there are 2 Americans stuck in the space station, but they should be brought home soon. So just a thought for them here. So that's an asteroid. Okay, so here what you see is the moon of Mars, one of the moon. So this one is very famous. It's another asteroid, but it looks like a potato. And so it's not dwarf planet. To be a dwarf planet, you need to be spherical. This one is like a potato, and it has its own tiny itsy bitsy moon as well that you don't see here. That's cool. Another asteroid. So Ceres was the first asteroid ever observed, the first one. And you see it's nice and spherical. So it was promoted to dwarf planet. So Pluto was demoted from planethood to dwarf planet, but Ceres, who used to be an asteroid, was promoted. Go figure, right? So it's part of the asteroid and it's spherical. So that's why it was promoted. So another dwarf planet with a very creative name, make. Pluto, insulting Pluto here, dwarf planet. Europa, you remember it's one of the moon of Jupiter, and it's very icy. They are sending a probe to Europa to see if you can find life maybe under the ice sheet. So that's the moon. Notice that it has a capital letter. It's the moon. Io is another moon of Jupiter. Mercury is tiny. It's the moon of Saturn, Mars, Sirius. Then use the Earth. So Kepler, each time you see a name like Kepler, it means it's an exoplanet. It's another planet, right? And this one is very special because it's like a planet like our Earth. So the first exoplanets ever found, they were very big, like Jupiter, because it's hard to get enough resolution to see the small ones. But this one is like Earth, so that's cool. Uranus, Saturn, it has rings, Jupiter, and then the Sun. So I think that's part of your pop quiz of today. Sagittarius A with like a star here. It's the black hole at the center of our Milky Way. And they did take a picture of it. Okay, so first they took a picture of the black hole inside M87. Okay, the galaxy M87. It was harder to get a picture of our own black hole, but they did it because you have so much dust and gas, but they did it. That's the name of our black hole. Red giant star Aldebaran. You remember Aldebaran is the eye of the Taurus, which is a bird. Rigel is part of Orion. You can see it with your naked eye. It's bluish. That's an interesting name. It's a blue hypergiant. So it means it's the star that star does not burn hydrogen into helium anymore. It's done. And it has inflated to a huge size. And it's called the hypergiant, blue hypergiant. So blue means it's very, very hot and it's burning, it's fueled very quickly. But it's done burning hydrogen. So it went to the next stage, which is burning helium or carbon or whatever element it's burning right now. It's called pistol because it's inside a nebula that looks like a pistol, like a gun. Betelgeuse, remember? Betelgeuse is also a supergiant star. It has left the main sequence, so it's not burning hydrogen into helium, and it's supposed to go as a supernova, but we don't know when. And this one is so cute. It's called Uiscuti. Uiscuti. So it's a very cute name, but it's really big. Okay, it's one of the biggest stars that we know about. So that's the famous black hole we took a picture of. More black holes. So the Crab Nebula, we will talk about it because it's the remnant of a supernova that happened in 1054. So it was early Middle Age. And the only ones who took notice of it, it had to be very bright in the sky when it happened, the supernova, which is an explosion of a big star. Everyone was seeing it, right? You cannot miss it because it's very bright. But only the Chinese reported this event. So they call that a guest star because it was not supposed to be here. All of a sudden you have something brightening and then dimming, like getting dimmer. And what is left behind is a neutron star. But only the Chinese reported that. So maybe in Europe, they thought it was some kind of bad omen and they didn't want to talk about it. We don't know. But anyway, it's called the Crab Nebula. Another supernova remnant. You have Kepler, Tycho. So going bigger and bigger. Milky Way. Andromeda. So in the pop quiz, I think I will talk about Andromeda. It's a galaxy. It's also called M33. So it's part of our local group and it's coming toward us. And we see it as it was 2.5 million years ago because it's 2.5 light years away from our galaxy. It's a giant galaxy and it's glued to us. So the local group that belongs to the Virgo supercluster, and then another structure. Remember Laniakea, which is immense heaven in Hawaiian. So we live somewhere there. And so it's a structure inside a structure inside a structure inside a structure. And this is the baby universe just after the Big Bang. And you see it's about homogeneous everywhere, but you see clumps of galaxies, right? Coming together because of dark matter, the blue. So there was another one, but I think I'm gonna save it for next time. Let's see. This is not the right class, okay? No. Okay, so we start a new unit. And that's physics, right? We don't want physics here. We are already done with that. We are done with that. So we start talking about history, especially interesting if you are non-science major. And if you are in archaeology, for example, or just history, I mean, history is interesting for everyone. So the first record that we have of observations done of the heaven, this is called the Venus tablet. So it's very famous, and it was it's reporting here the position of Venus as seen from the Earth over a period of 21 years. So it's the oldest, right? It's like a diary, and it's the oldest one. And what is also interesting if you are in archaeology is that it's written in the oldest writing system, and we call that cuneiform system, right? So it's written in this writing system. So it's like a little stick here. So it's the oldest one. It was developed by the Sumerian in what became after Babylon, right? Babylon, which is now it's Iraq. Okay, so it was developed by the Sumerian. If you know the Bible, for example, Abraham came from that region as well, from Babylon, and the Babylonian were very much into observing the sky. Okay, so those big towers here, they were looking at the sky. Not they were very interested in what's going on in the sky, but they use the position of planets also to predict what will happen. Astrology, right? And like to say, is it good to change your boyfriend or your girlfriend? Is it good to harvest now, not to harvest, to go to war, not to go to war? Okay, so it was a job. To serve the kings, to say what's gonna happen next, what you should do. So that was in Babylon. And again, the oldest report that we have is very famous, and it's called the Venus planet. So you have the position of Venus recorded over a month. Okay. So here I'm going to use an old website of mine. You will find it also in the Dropbox. Okay. Because it's easier for me, it's big. So you have access to it, or you can stick to the slides. So it started with the Greek here, right? And they are the one who came up with the geocentric system. So the Greek had a thing for anything circular. They thought that a circle is a perfect shape or a sphere is a perfect shape. They loved everything circle. And if you don't see the planet going around the circle, it's that because you don't see well. Okay, it's you. It's not the it's not the planets. So they came up with that system here, which is called a geocentric system, where the Earth is at the center and the Sun is orbiting the Earth. And then, of course, that was before Newton, so they didn't know about gravity gluing everything together. So they decided that here, again, they love spheres. So here you have what is called a celestial sphere. Maybe it was made of crystal, and all the stars are glued, maybe by the gods, on that sphere. Yeah, I don't know. I think I already showed you another picture. Can you see it? Okay. I cannot look at you and look at my computer glasses, which is very annoying. So anyway, so you have the Earth and then the Moon, and then you have Mercury, and then you have Venus, and then here you have the Sun, and then you have Mars, and then here you have the celestial sphere. So that was the idea at the time. So that was developed by the Greek. And then you have someone named Ptolemy. So it's in Egypt. So at the time, Egypt belonged to Greece, right? You have the Babylonian and then the Persian and then the Greek taking over that region in the world. So Ptolemy said, okay, it does not fit what we observe. It doesn't fit the observations. We have to fix that system. So he's the one who came up with what we called epicycles. So he didn't want to remove the Earth from the center because humanity is so important. We have to be at the center of everything. But he came up with, let's go back to my website here. He came up with epicycle. So try to fit what we were seeing on Earth. He said, okay, for example, if you have Mars, it's going around the Earth, but also it's going around circle, which is called epicycles. And it still didn't fit well. So they built like epicycles on top of epicycle, try to have some fix, cheap fix. You know, when you rent an apartment and it's a cheap, it's not expensive, but it's a cheap apartment. They do a fix and then another fix and another fix and then another fix, right? Layers and layers and layers of fixing, trying to fit what you are observing in that case, but they didn't want to put anything but the Earth at the center. So if you are taking an economy class, you know, in economy, a good model, a good economic model should be simple and easy to explain. And if it doesn't fit what you observe, what they do, they add cheap fix. In economy, it's called epicycles, right? So you have a model, it doesn't fit what you're observing. You don't want, okay, you don't want to start over. So you're gonna add a fix on top of a fix on the top of the fix, and becomes very complex and no one understands anymore. So this is called epicycles. So the economy field took that word from astronomy. So it's a cheap fix on top of a cheap fix. So it really was very, very messy, but no one wanted uh, to talk about that, right? to challenge it. And then you have Copernicus. If you have any question, let me know. Okay, so Nicholas Copernicus here, he was, where is my mouse? I don't see my mouse. Okay, he was Polish, right? And he was a lawyer and a doctor by trade. And he thought that it didn't make sense, that it's too complex, too complicated. And he changed the model and he said, okay, if we put the sun at the center and then Mercury and then Venus and then the Earth and then Mars, Jupiter, then it will make sense, right? But you could not mess with the Roman Catholic Church at the time, you will get in trouble. So he was being very, very careful. First of all, the book that he wrote was in Latin, and no one could read Latin. I mean, certainly not the people. It was only for very educated people, very wealthy people from very famous, great families. So that's one way. And then he made that book kind of complicated, so it was not straightforward when you read the book. And third, he waited to die. How smart, right? He was in his deathbed and about to give his last breath, and then he signed the book to be published and bye, I'm out of here. So that was very smart because he didn't want to be burned at stake. And I think in 2010, so that's how, my slides are very old. Actually, 2010, they found his tomb and they changed the burial site. And they did some DNA analysis. So let's see if I have a picture of Copernicus' book. Copernicus here. Okay, so of course that was translated, but it was in Latin. And if you open the book, you see here, it had a drawing there, right, with the sun at the center. So this is called the heliocentric system. You still have circle, because the one who said it doesn't have to be circles, it could be ellipses. That will be Kepler. But Kepler was not around yet. But he was very, very, very careful. And someone else here was not very careful, right? His name, very famous. His name is Jordano Bruno. And he liked, of course, he was a monk, so he was able to read Latin, and he very well understood the meaning of that book, right? And he said that Copernicus was right. Not only that, he said that it's very possible that you have other planets, and now we know that it's true. And then maybe you have life on other planets as well, right? That we don't know, maybe, but it might be true. And he had to leave Italy, and he went to Germany and exposing his ideas, and that was fine. He went to Germany, he went to France, and he went to England. So in England at the time, I don't know if you know Elizabeth I, right? Elizabeth I was very open-minded when it came to science. Not to everything, but when it came to science, she was a patron of science, so she was very clement to him. So he could speak freely in England. But you see, you always have to be very careful. He was not being very smart because he came back to Italy because he was hired as a tutor for a student. A guy, and he was supposed to teach his students ways to memorize things, like techniques to remember things. And that didn't go well because they argue together, and the employer, right, who took him as a tutor, got upset, and as a vengeance, he told on him. He went to the church and complained about him. And so Giordano Bruno was sent to Rome. There was a very famous trial, and he was burned at stake, naked. So it's a very unpleasant death. So sometimes it's good to have your mouth shut and not to get in a dispute with people who have a lot of connections sometimes. Right? So I don't know if you have what's the name of this guy? Monchenigo. I don't know. Monchenigo. No, Monchen. So you see, it's a very famous family in Venice. So in Venice, it was called the Doges in charge of Venice, and the tutor of Giordano Bruno was very influenced, right? So he was part of the Doges, and it's him who, I don't know if it's really him. I don't know. No, I don't think it's him. But one of them sent Jordano Bruno to be burned at stake. And it's sad because he was only 52 when he died, and his trial took a lot of time. So this is interesting because I went to Rome, and there was a very famous plaza which is called Campo di Fiori, which is not far from the very famous fountain. And so you walk there, and every morning you have a great market with great cheese, amazing cheese, not like the American cheese. But at the center of that Campo di Fiori, you have the statue of Giordano Bruno, because he was burned at that very location, at the center of the plaza. And if you go around, I don't know if you can see here, I don't know if you can see the detail, but here around the statue, you have the story of his trial and how he died. Okay, it's engraved here all around. So it's a very cool place to visit, and it's in Roma, right? It's a great place to visit. I love Italy. Everything is nice in Italy. So anyway, so that was for Giordano Bruno. And it took a very long time for the church to recognize that was not very nice of them. Giordano Bruno. Okay, so it was in 1600. They said it was sad episode. Yes, when you are burned at stake, you can call that a sad episode. Right? Any questions? And then come the great Galilei, Galileo Galilei, right? And there are so many things to say about him. So the first thing I could tell you is that, and definitively on the test, for example, he is the one who improved the first refractive telescope. Okay, so like binocular refractive telescope. And then he didn't invent the telescope. It was made by someone Dutch, and it was really like a toy for the kids, right? So he got interested in the design and he improved the telescope, right? And he was the first one to turn that telescope to the heaven. And he started to study all those celestial objects. I mean, he was the first one to see the ring of Saturn, okay? And at the time, he could not see the whole ring. He was like handled on both sides. Now, if I can show you what it looks like. Yeah. What he saw, he could not see the whole rings. He just saw like handle, like ears on both sides. So anyway, he got very rich because he gave his telescope to the people in charge of Venice. So they were the government of Venice was delighted because Venice is an island, and at the time they were always at war. So thanks to that telescope, sorry, they were able to see the ships coming 2 hours earlier. So 2 hours makes a big difference to prepare for war, right? So they were so happy that they gave Galileo a tenure. I don't know if you know what's a tenure. when the professor has a tenure, you can write as bad evaluations that if you want, there is nothing that will be done because tenure means you cannot be fired unless you do something really bad. So he had tenure, so he had a lot of money, and he was teaching at the University of Padua that belongs to Venice. And then he moved to Florence because there you have the family of Medicis. You know, you all heard about the Medicis family, and they were also patron of science. So he was supported by them. They were his patron. So that way, he didn't have to worry about money, and he could observe the sky. Okay, so that's the story of Galileo. So what were his observations? So first, he was the first one to observe the moons of Jupiter. Then let's go back to here. So here you have the telescope. Okay, and if you go to Florence, there is a small science museum, and you can see the telescope, a replica of his telescope. So that's a picture of that, and Galilean moon. So he was the first one to observe the moons of Jupiter, and that was also interesting because even though Jupiter was going around the sun, it didn't leave the moons behind. It means that the moons were following Jupiter. So it means that one of the arguments of people supporting the geocentric system, they said that if the Earth was going around the sun, we would have been left behind because the Earth is moving, so we are left behind. But because they didn't know about gravity at the time. So he said, look, the moons are still going with Jupiter and they are not left behind. Okay, so he supported the Copernicus system, the heliocentric system. And soon he will be in trouble with the church because not only he was supporting Copernicus system, but the book that he wrote about the Copernicus system was in Italian. So everybody could read the book, not even in Latin, right? So he didn't take that step. He wanted everyone to know about it. He got in trouble, but as you know, connection. So he had connection. So he was not burned at stake. Oof, that's good for us. And he was under house arrest because he was supporting the Copernicus system. But once when it was the door was open, that was it, right? And then everyone understood that the Copernicus system, the heliocentric system, made more sense. So here you have it's a page from his book, and you see he was observing Jupiter and the four moons of Jupiter moving with it, and it was in Italian. Here you have another drawing comes from his book. So this now it's in English. Okay, you can find the translation. So he wrote Galileo had published 3 books. So in the first book, he was warned. Okay, be careful not to open your mouth too much, you're gonna be in trouble. So that was in 1610. Okay, it's called Starry Messenger, and in that book he drew the moon, he drew the moons of Jupiter, he drew Saturn and the phases of Venus, right? But he was warned. Okay, be careful, it's dangerous, you are taking a dangerous path. And then what he did in 1632, he wrote this very famous book, and it's dialogue concerning the two chief world system, where he kind of made fun of the church, of the Pope at the time. So the Pope liked Galileo first, but he didn't like to be made fun of because in that book described a dialogue between 2 people, and one of the people was supposed to be the Pope, and the other people was supposed to be Galileo. It was not that hard to understand that. so it didn't go well with the church. So he was there was a trial. He was arrested, but connection. He was under house arrest, and that's a good thing because Galileo was a genius, but it's the kind of people who cannot rest, right? They are always onto something. So he's doing research here, research there, never taking the time to write down everything he found out. So now that he was under house arrest, he started to write about his discoveries about kinematics, free fall and kinematics. Isn't that interesting? So let's see. If you go to Florence, so don't go in August, right? It's super hot and super humid. It's not very pleasant and it's full of people. But if you can go, in spring for spring break, it's amazing city, a lot of things to discover and to visit. And one of those things, it's the house of Galileo, where he was under arrest. And you see here, you have a painting of Galileo. Let's see. It's not, there are so many things to say that it's not in order. Um, okay, so after his first book, he was warned. Okay, so he had a lot of connection and he was warned. They told him, be careful. Okay, it's dangerous. But luckily, he was not burned at stake. This is also a very famous painting. You see his trial with the church, right? He got in trouble. Um, he also is the first one to understand that the sun, so the Greek and later in Europe, they thought that everything had to be spherical and perfect and smooth, like the moon and even the sun. And he's the first one to have spot. I mean, spotted spot, right? He's the first one to observe the sun spot, right? So it's dark, little dark spot here. That's because the temperature here is a little bit cooler than here, right? And he's the first one to draw this, and it cost him a lot because what do you think happens if you stare at the sun too much? Yes, exactly. He became blind. Okay. For the rest of his life, he was blind. So don't stare at the sun. That's not such a good idea. He's the one who spotted for the first time the rings of Venus. Looks like handle. Okay, he was describing handles because he didn't understand. Of course, he didn't have a good telescope good enough, so he didn't understand that you had rings here. So okay, also another challenge of the mainstream ideas of the time. The moon was supposed to be spherical, perfect, and smooth, and it was not. Okay, so he's the first one to see the craters on the moon, right, and the mare, which is old lava flow. So I know if you have a modern picture of that, you have the ring of Saturn. See, you have craters here on the moon. So he's the first one seeing that. And then what else? So there is one of his students. What's his here? No, that was not this one. This guy here, he told him, if you want to prove the Copernicus system, look at Venus. Look at the phases of Venus. So Venus has phases like the moon, exactly like the moon. And the only way you can explain the phases of Venus is if the sun is at the center. If you place the Earth at the center, you cannot explain the phases of Venus. And he didn't credited the one who had this idea to look at Venus, but the phases of Venus, and typical question, for assignment or a test, the phases of Venus was the nail in the coffin of the geocentric system. So I don't know if I can show you why, if Venus phases, okay. maybe here. Okay, so if the Earth is at the center of the solar system, okay, so that will be the uh, geocentric system, you cannot explain why Venus has phases. But if you place the sun here and then Venus around and the Earth around, you see that as seen from the Earth, Venus will have phases. When it's there, you see it's all shiny because it's reflecting the light from the sun. And then as it goes around here, when it's there, you see you don't see Venus anymore. It's all dark, okay, because it's not highlighted from our perspective, our point of view. And then you see it's going to go around. So the only way you have to explain why Venus has phases is to use the heliocentric system. And he got that was the nail, right? That meant that Copernicus was right. There is nothing here. Okay. So again, the first book of Galileo, it's called the Messenger, Siderian, the Siderian Messenger, and he just described what he had observed. And then the second book is the one who got him in trouble because one of the character here looks very much like the Pope, and the one who is teaching everything looks like Galileo. So it didn't go well with the Pope. Okay, he got upset, didn't like that book. And then the last book, that's the book about the geocentric versus heliocentric system. And the third book, it's going to be about kinematics. That was also in Latin. Did I show you everything? Okay, and funny story. If you go to Florence in that so Italians have a lot of humor, okay? A special kind of humor. And if you go to that museum in Florence, where you can see the telescope of Galileo, at least a replica, they also put his middle finger. So you can interpret that as you want, right? So usually you have bones in churches, right? So they found that it would be very funny to have the middle finger. Why the middle finger? You can imagine why in that museum here. So you can see it if you go to Florence, right? It's an Italian sense of humor. That's interesting. And then when he was so that was early. Before he started to observe the sky, he did a lot of discoveries concerning free fall, right, and kinematics. And it was just on time for Newton because when Galileo died the same day or just the day after, Newton was born. So the story says that Galileo went up to the Pisa Tower here, right, because Pisa belonged to the government of Venice. At the time, it's not that far, it's a few kilometers away. And he did all those experiments, right? And the idea is that if you forget about air resistance and if you take something very, very heavy and something very light, okay, they will reach the ground at the same time, regardless of the mass. And that experiment was done on the moon. Okay, so they took a hammer and a feather. There is no air on the moon, there is no atmosphere. Let them go and reach the ground at the same time. So the story goes that he did those experiments from the Pisa Tower, but it's not really true. What he did is even smarter. Okay, the guy was a genius. He used what it's called a inclined plane. So when you have an inclined plane, okay, and you have a sphere going down, it's still acted upon by gravity, but the gravity will be diluted. So it will have time to measure um, the time it takes. So doing this, he was able to show that the kinematics law that you study when you take physics, right? So it was a great idea. So now I can show you if someone has a book, I can show you the idea of free fall. Regardless of their masses, all objects will reach the ground at the same time. Someone has a heavy book, it's like a book, a textbook. That's the problem with the modern time. People don't have textbook. Let's put something heavy. Try. Okay, thank you. Gabriela, right? Yeah. Okay, so you see, you have a paper and you have something heavy. So of course, you're going to say which one will reach the ground first. The paper. But if I put the paper on top, right? So now the paper is shielded from air resistance by rainbow. What do you think is going to happen? You think that it's still a binder reaching the ground first? It's around at the same time. So if you were on the moon and if you have a feather and a hammer, and it was done by the astronaut, right? And you let go, they will reach the ground at the same time. So he could not explain it. Why? So he took Newton come and explain. The reason for that is that, of course, you're going to have more gravity. Yes, the gravity is pulling even stronger on the boat, right? So the weight will be larger, but at the same time, it has more inertia, more laziness to move. So both will cancel each other out. So this one has less weight, so less pull, but also it has less inertia. So if you take physics, you know that F equals ma, but the weight equals mg. So that means the acceleration will be the same. Thank you so much. So that's why Newton said, if I have seen so far, it's because I am standing on the shoulders of giants. That's why my unit was named like this, the shoulders of giants, right? So he did all those experiments here about kinematics. And then when he was only 17 years old, he was at, I don't know if it is true, but when he was 17 years old, he's the one who discovered that if you have a pendulum, you see a pendulum is a string with some mass, the time it takes to go back and forth only depends on the length of the string. And the story goes that maybe he was bored at church, right? He went to go to the cathedral. So it's a cathedral next to the Tower of Pisa. And he looks at the incense. See, sometimes they have an incense here on the string. And he was using his pulse to measure the time it takes to go back and forth. And that was a great discovery because then he used the pendulum to measure the time as a stopwatch. Okay, because if you take a length here, just right, 25 centimeter, the time it takes will be exactly 1 second. So he didn't need his pulse anymore. He used a pendulum to measure the time as a stopwatch. I don't know if I have a picture. Uh, I don't know if you can see it. So this is also a replic, and you can see this replic also at a museum at the Science Museum in Florence. But you can see here he had a small pendulum, and he was using it as a stopwatch. And then he did all those experiments to show that the distance covered in a given time is proportional to the time square. Just about this, you don't need to know that, but you remember that he used a pendulum as a stopwatch, and he did all those experiments in kinematics, so the study of motion. So he was really the first one to open the door to physics or science based on observations and not based on, the weather of today, philosophy or religion, right? He was the first one to base his statements on hands-on experiments, demo. So I don't know if I had the video of the hammer. Let's see, golden eye. Okay, so that was done on the moon.
Jim, we copied both solar wind and penetrometer drum in the ETB.
Not quite yet. I haven't put the solar wind in yet, but I will shortly. I want to watch this. Joe, you have a good picture there. I've got...
Beautiful picture, Dave.
Well, in my left hand, I have a feather. In my right hand, a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the two of them here, and hopefully they'll hit the ground at the same time. How about that? It proves that Mr. Galileo was correct in his findings.
And isn't that cool? It's a very famous video, okay? It's taken on the moon, but you can also do the experiment on Earth, right? So you have this big chamber. I forgot where it is. I don't know if it's in Michigan. I'm not sure where it is. Maybe he's going to say it. But you have those big chamber where you can remove the air and do the same experiment. So you don't have to go to the moon. Oh, it says here, when was it here? Apollo 15, 1971. Zero air resistance, even though you see the mass is not the same. Okay, but nevertheless, they reach the ground at the same time. So it's the biggest vacuum.
This is NASA's Space Power Facility near Cleveland, Ohio, and it is the world's biggest
Cleveland, Ohio, not Michigan. Sorry.
vacuum chamber. It's used to test spacecraft in the conditions of outer space, and it does that by pumping out the 30 tons of air in this chamber until there are about 2 grams left. And it's kind of got an eccentric construction, which is part of its history. It was built in the 1960s as a nuclear test facility to test nuclear propulsion systems. And that meant that they built it out of aluminium to make the radiation easier to deal with. Aluminium is not the best thing, the strongest material to build a vacuum chamber out of. So they built an outer concrete skin, which is part radiation shielding and part an external pressure vessel. So this thing can take the force that's present on the outside when it's pumped out to the conditions of outer space. Galileo's experiment was simple. He took a heavy object and a light one and dropped them at the same time to see which fell fastest. Now in this case, the feathers fell to the ground at a slower rate than the bowling ball because of air resistance. So, the true nature of gravity, we have to remove the air. It takes 3 hours to pump out the 800,000 cubic feet of air from the chamber.
Okay, we dropped 2 millitorr in the last 30 minutes.
But once it's complete, there's a near perfect vacuum inside.
6104 manual, 10% open. Station 1, go for drop. PCP 30-1, pressure set at 240 psi. ER, go for drop.
10, 9, 8, 7, 6, 5, 4. Cameras on. 2, 1. Release.
Exactly. They came down exactly the same. Wow.
Look.
That's right there. Look how they hit right there.
Exactly.
Back on the side.
Exactly the same.
Feathers don't move, nothing.
Look at that. That's just brilliant. Isaac Newton would say that the ball and the feather fall because there's a force pulling them down, gravity. But Einstein imagined the scene very differently. The happiest thought of his life was this. The reason the bowling ball and feather fall together is because they're not falling. They're standing still. There is no force acting on them at all. He reasoned that if you couldn't see the background, there'd be no way of knowing that the ball and the feathers were being accelerated towards the Earth. So he concluded they weren't.
So he's a very famous public speaker and a physicist. Okay, you can find his videos on YouTube, for example. What he's saying is that, so Newton said that the reason things are falling on Earth is because gravity is pulling on them. And the reason a feather and a hammer will fall at the same rate is because of, if you have more pull, you also have more inertia. So which means if you are pushing like a truck and a bike for the same force, of course the truck will not go as fast because it has more laziness. But Einstein came and he said that sounds very complicated. It must be more simple than that. And that's when he said that actually what's happening is that the space-time is curved. So here it's curved in 2D, but it's actually curved in 3D. And the reason we go toward the Earth is because space itself is pushing us toward the Earth, right? So if you have something very light or something very heavy, like you have a penny and a quarter, they will go around exactly the same way, and they will keep going around forever, right? So turns out that gravity is just an approximation, but it's enough to send people to the moon. Okay, so about Galileo, I think I show you everything I wanted to show you. Let's go back to my website. So again, the link is in the Dropbox. So he didn't drop objects, right? He used inclined plane, but they are still falling down, but the gravity will be diluted because you have a slope. But if you go down slope, obviously it's because of gravity. Right. So then next comes Kepler. Okay, so very interesting story if you like if you like history, because he was born at a time when Europe was at war. Europe is always at war, right? It's still today. They always fight against each other. So anyway, that was a time when the Catholics and the Protestants didn't agree, and there were a lot of war. And for example, in France, maybe you heard about the Saint Barthélemy massacre, right? So it's when So I forgot who was in charge. It's a Médicis. I don't know if it was Marie of Médicis or someone like this. The Queen of France decided to kill. It was a bloodshed Protestant. So that's when Protestant decided to flee, and that's how they came to the US. So if you go to New York, for example, around New Paltz, for example, you still see those old houses that were built by Protestant. We call them the Huguenots, right? The Huguenots, and they were fleeing France because Catholics were trying to kill them. And after that, you have the 30 Years' War. Okay, so it was like around 17th century, and they were still fighting. So Kepler was very unlucky, didn't have a happy life. Okay, he had like 11 kids and 7 of them died. He was married to a woman who was like not very nice. A lot of things happened to him. He had to flee Germany, and he went to Prague, and that's where he met Tycho Brahe. So I will tell you the story, interesting story, next time.